that
Get him,
that's
Robert.
that's very arbitrary.
It's a perpetual motion machine right under these people's feet. It's a perpetual motion machine right under these people's feet.
Yeah, but how do you tap that? Give me your science on tapping that. Go.
Yeah, I'll do that just after you tell me what the universe is expanding into.
Nobody knows, brother. We just know it's expanding. That's all. That's all the science says.
What says it's expanding? What do you use to make that determination?
Red shift, blue shifts, these kind of things.
Okay, and how do you know that redshift is mutually exclusive to the universe expanding?
It is mutually exclusive to how light works, brother. Back to
okay.
school.
I guess you've never heard of Halt and Arp, have you? Maybe you should go back to school.
Yes, I have that. So red shifting, red is has the longest wavelength. So when an object is moving away, it will expand. It will reach further on that red spectrum. Yeah, that makes sense.
Yeah, I know. I know. I've been to school too, and I understand red.
I know you know. You just have something in your mind that says, "I don't want to hear scientists speak. I hate scientists." I hate them.
So when I said Halt and Arp, you've not heard of him, or probably since the way you
I know who you're
responded was
talking
not.
about. That's garbage.
So what did he? So no, it's not irrelevant.
Toroidal magnetic electromagnetic.
Has nothing to do with him. That has nothing to do with him. So
absolutely does. Yes, he does.
Yes. So his work, he was actually an extremely renowned, well-recognized scientist who had been working professionally for 40 plus years, I think. Anyway, he was an astrophysicist in terms of the work that he performed, and he found that when he was doing these measurements of galaxies all over the celestial sphere, which is what I call it, you could say the universe, but either way, when he was doing these measurements, he found that certain galaxies and star clusters that were closer had more redshift than ones that were further away, and vice versa. And it was not consistent like it should be, because the further something is away or the faster something is expanding will affect the rate of redshift that you're supposed to see. And the observations did not fall in line with the assumptions of the model. So what he did is he showed and he demonstrated that the mainstream model of redshift when it comes to the sky is not consistent, and therefore the conclusions that they come to can't be true.
Hey, Jeremy, can you drop down?
Robert's going to have to update his script.
Real quick, guys. Jeremy, can you drop down into VC2? I got to discuss something with you real quick.
All right.
But yeah, that's all I wanted to say. So.
What up, Piezo?
What's up, dude?
I wanted to hear this, but I'll be right back.
Okay. Did somebody mute that guy? I was waiting on him to respond. I think he's muted.
Yeah, he's muted. I think you can unmute now.
Yeah, Robert, you're good. You're good to unmute now. Don't clip. If someone's talking, don't talk over him.
Well, you guys don't clip me either. Stop being hypocrites. Okay? Let's be fair. Okay? So, brother, the size of the object is what's in question. A very small object can redshift when it's close to you. Right? It only has so much photons that can reach you. Due to the inverse square law, its level of intensity may not show up on the visible spectrum if it's moving fast away from you. But it's pretty close relative to very, very large, small, very, very far large objects. So what your friend scientist, that you world-renowned guy, left out relative size, he left out angular size, he left out intensity, and he left out the inverse square law in his garbage. He's outdated. He's never looked at the data from the James Webb Telescope. He's never looked at the data from the Hubble Telescope. He's done. Stop referring to old, outdated people. Flat Earth is 2,500 years old. It is done. Okay? Thank you very much.
Yo, Robert, do you Oh, he's gone. I guess he got us.
Yeah, he wasn't interested in learning, bro. He just wanted to talk. Like everything he just said, he doesn't even know who Halt and Arp is, nor is he familiar with any of his work. He just made a bunch of like railing accusations that he doesn't even know if they're applicable or not.
Did that guy take into account the size and all that, or is that just like ridiculous?
He wants to act like, dude. He just claimed that Halt and Arp didn't know the inverse square law, something that you learn in like undergrad. He just claimed that he didn't take into account the inverse square law. He just rattled off a bunch of words that didn't have any coherent or sensible meaning in the context of what was being talked about. Anyways.
And then he left. So I guess he got us
because
he got the last word in. Now Robert's
what were you
saying,
man? Jeremy, before you said you wanted to hear something. What were you saying? Were you asking a question?
You usually come with some like dope ass shit. I mean, you sent me that whole long DM, dude. Like, I don't know, man.
Oh yeah, did you read it?
I read it, but like, I was gonna send you a DM back. I was waiting to read the last one you sent so I could DM you back and tell you to just doing VC because I do better with like audio.
Okay. Yeah. So, all right. So I did more
This was for the sun.
research.
This was for the sun changing because
Yeah.
off of the equator, right?
Yeah. So I was doing some more research from when I was in here like a week ago, talking to whoever that one dude was. And I wanted to
That was
verify
Danny
everything.
Faulkner.
Okay. I don't. Who's Danny Faulkner?
He's a PhD. He wrote the book Falling Flat, basically roasting us. The dude, and I think Nathan Thompson approached him at one of the conventions. The dude was like, he was like, I have all the answers. You guys are checking the internet for the answers for these flat earthers. He's like, you need to come to me. I have all the answers. And then Nathan Thompson asked him at one of the flat earth conventions, how do you have gas pressure without a container? Faulkner went and looked up blue marble shit and used that as the fucking off the internet as a citation. It was just funny.
He's
Okay.
usually in here. His name's Danny47.
He's got a
something like that.
PhD though. So
He's an astrophysicist, bro.
no,
Okay.
he's an astronomer. He's an
Or
astronomer.
astronomer.
I went back after that short talk we had with him, and to verify some information. So I had to learn a little bit just to make sure the stuff with the calendar wasn't wrong. So basically, if you guys imagine that you're in not the Earth-centered inertial frame, but the Sun-centered inertial frame. So you're centered on the Sun, and you're in the center of the solar system, and everything goes around you, right? Okay. In that frame, that's how we define a year. A year is defined in that frame. So 1 year, the definition of a year is the amount of time that it takes the Earth when it moves in its orbital circuit, doing its revolution around the Sun, to return to its starting point. So any point that you pick, you go 1 year, the Earth will go all the way around the Sun and return to that exact spot. That is the definition of a year. Okay. Now, in 45 BC, we moved to the Julian calendar, and the Julian calendar was attempting to make up for the ever so slight difference in the year, because a year is not an exact number of 24-hour days. So what the Julian calendar did is it said, we're going to invent a leap year, and it's going to be 365.25 days. So every fourth year we'll have an extra day, like we do now in February. But the problem is it wasn't precise enough down to the decimal point level, because a year is not actually 365.25. It's like 365.2422 or something like that. Yeah, bunch of decimals. So what ended up happening is it was a little bit, the year defined in the Julian calendar was ever so slightly longer than a true year. So they were gaining about 11 minutes and 12 seconds to 11 minutes and 15 seconds per year, depending on who you ask. And so over the years, that 11 minutes and 12 or 15 seconds a year built up, so that by the time we get to 1582 AD, it had been 1600 whatever the number is, 1600 something years. And when we get there, they had gotten like 10 days ahead. Okay. So what they did in 1582 is they moved to the Gregorian calendar, and they skipped 10 days in order to make up for that 10 days ahead that they were, so that now they're back to the right date. Okay. Because what had happened is it was causing the equinox, which was supposed to be March 21st, it was causing the equinox to shift all the way to March 11th. So they skipped 10 days to make it get back to where it was supposed to be. Now here's the problem. That's all fine. That's all good. We now know that we have a calendar that precisely captures what a year is. Okay, so the rule is every 4 years you do a leap year, and then like every 400 years on every century, every fourth century you don't do it. I think that's what it is. You don't do it every fourth century. So like basically over a 400-year period, you'll go through enough leap years and then skipping a leap year in order to maintain like perfect decimal point level symmetry. Okay, so 1582, the equinox was March 21st. You fast forward till now, it has now been 443 years. Now, we know that the calendar is accurate, so we don't have to worry about any calendar deficiencies. So the calendar date should stay the same in terms of that. But we still have another effect that's messing with stuff, which is known as the precession of the equinoxes. So they claim that Earth's axis, the stick that runs from North Pole to South Pole that goes straight through the ball, the axis that Earth is rotating about, that actual axis itself is turning. Like the whole stick is turning, swiveling around in space. So that over a period of around 26,000 years, it will do a 360-degree rotation. Now, the reason that they say that they know this is because every year on the equinox, astronomers all around the world for centuries have been taking measurements of the stars and plotting coordinates for the stars. And so by measuring the stars and the other bodies in the sky at solar noon and solar midnight on the equinoxes, this is how they plot the nautical almanacs and stuff. And so what they found is over the years, over the centuries, the actual stars themselves, the entire celestial sphere, as I call it, has been precessing with respect to the position of the sun, or the position of solar noon, solar midnight, at a rate of about 1 degree for every 71.6 years, or you can round it and say 72. So every 72 years, roughly, you gain a degree. Okay, the whole thing rotates around by 1 degree. Now, in their model, what would be causing that? They have to say that the cause is Earth moving, right? Because that's what causes everything in the sky to move, is it's actually Earth moving, right? So they have to have the same cause. It all has to be Earth motion, Earth rotation. So, or Earth axis motion. So the problem that we get to, though, is that what should happen, because since the Earth itself, its axis is turning, what this will cause to happen is if you go in 1 year increments, so let's say that we start on March 21st, and we just advance our time slider, we tick the arrow on the year box and just go forward in only years, then that means that we don't change the position of Earth with respect to the sun around its orbital circuit. It stays in the same spot. The only motion that we'll see is Earth's axis will start turning when we move that year slider. So moving the year slider will turn the Earth's axis. Now, what this will cause to occur is the equinoxes, the seasons themselves will begin to shift relative to the date on the calendar. Because since the calendar
That would throw an equinox off.
Yes, so since the calendar is fixed now, the only thing that can change is where the seasons fall on the calendar. So what should happen is we should be gaining, 1 degree per 71.6 years. And so by now, in 443 years, we should have gained about 6 days. We should have gained about 6 days in that 4.
That's not happening though.
So you're saying
Not happening.
that the globe model says that that there's this wobble and the equinox should be shifting ever so slightly over the
It
course
would
of time
have
as that
to.
wobble.
Yeah, it would have to. This effect is known as the precession of the equinoxes. Look it up. It's a necessary consequence of the fact that at the same exact point in the orbit, year after year, Earth still returns to that spot, but its axis is now different. Its axis is now pointed in a different direction. So if you think about the ecliptic plane of the solar system as it crosses over Earth's equinoxial plane, the equinox is defined as when 50% of that equinoxial disk is above the ecliptic plane and 50% is below it. When it's 50-50 balance, that's the equinox. So since you twist the whole Earth axis around now, on March 21st, we'll no longer have a 50-50 distribution. Over time, it'll be 51-49, 52-48, 53-47. So the day that the equinox will occur will shift on the calendar. So since the Gregorian calendar was instituted in 1582, the equinox was March 21st that day. And now, how do we know that? Well, number one, they documented it. Number two, the reason was because who instituted this change? It was instituted by Pope Gregory of the Catholic Church because the Council of Nicaea in 325 AD had established we shall say that the equinox is to be March 21st, because they were using it to calculate the date of Easter, and they wanted Easter to always align pretty close to Passover for religious purposes. And so 1582, it had gotten so far off that he said, we got to fix it. We got to reset it and fix it before it gets any further. And so now we know 1582 had a March 21st equinox, or 1583 or whatever. Now it's 2025. Now the equinox should be off by 6 days. It shouldn't be March 21st. It should now be March 27th or March 15th, whichever direction it moves. I'd have to think about it.
Yes, sir. I'm so happy that we're bringing this forth, dude. Because you heard of archaeoastronomy at all?
Yeah, so that's where this ties into. This ties into
That's his main point.
archaeoastronomy, because not only has the equinox date not changed in the past 443 years when it should have to, we can look at archaeoastronomy. Yeah, we can.
Yeah.
Yes, we can look at archaeoastronomy and show that all these sun temples that were built with respect to the motion of the arc of the sun as it moves across the sky on the equinoxes and the solstices still properly track the sun the same now as they did thousands of years ago, showing that the arc of the sun, its path trace across the sky, has not changed. And also, since we know that the stars in fact do precess, I mean that's an objective measurement. They claim it has to be Earth motion. Since we know that is happening, but we know that the relative orientation between the sun and the Earth is not changing because the equinoxes are not precessing, that means that the cause of the precession of the stars is that it's just the stars are moving. The celestial sphere itself is precessing. It has to be the stars moving, because if it was the Earth moving, it would also mess up the relationship between Earth and Sun. But since the relationship between Earth and Sun has remained fixed and we know it's not moving, the only option left is that it's the stars that are actually moving.
Yeah, you can't change that 66.6 degree tilt and keep the equator the same. I mean, maybe if you change the orbital plane at the same time too, though. I don't know what kind of excuse they got for this.
No, yeah, and the tropics would shift.
You'd have to change the orbital plane at the same rate and same time as the tilt was shifting.
Yeah, so that's the problem that they run into, because they can change calendars and they can correct things to make it more precise to a solar year, and they can do all manner of corrections on that respect, but they can't change what the sky does.
And so they predicted this shift in the tropics and in the equator. It's part of the Milankovitch cycles, but it doesn't match up with archaeoastronomy. Their predictions, how much should change is not matching up with reality.
There are tons of equinoctial markers, dude. Tons, dude. The Sphinx is one of them. Tons of the megalithic sites are they got them facing east west. The Great Pyramids one.
Yeah, I mean they have
Just tons
like a. Oh, sorry.
No, go ahead.
Well, they have all kinds of temples around the world that have different types of topology and architecture on them that will have marker points that will mark, the position of the sun at like certain hours of the day, whether it be noon or whatever it is. It varies between the markers, but those things are all still lined up. And even if like based on your latitude, let's say you're 45 degrees north latitude, even if the sun reaches a high point of 45 degrees because your latitude's 45 degrees on the equinox, the sun the solar altitude is going to match your latitude. Even if that's still true, no matter how the orientation works, the arc that it takes to get there, right, relative to you, is going to be different if you are in the same orbital position, if the Earth's axis precesses. As long as we're measuring
such tricky math, such tricky things to do that, because you could shift the axis, keep the equator, the equinox the same. You'd have to shift the orbital plane at the same time at the same exact amount you would need to make that happen.
Well, they made it easy for us, bro, because the calendar is precise now. Because we are on the Gregorian calendar, we know that the Earth every year is at the same starting position it started its circuit at last year. We've got the year down to a precision level. So all we have to do, since we've eliminated calendar imprecision, the only factor we have left is axis precession. So we can just look back in time at what date the equinox falls to measure that axis precession. Well, dude, there is no axis precession. It's the 21st in 1582, and it's the 21st in 2025.
That's right.
It hasn't changed.
In 2,000 years, I think it was like something like 20 days. They should have shifted between summer, winter, and the equinox. So not just the solstices, but the equinox, bro, should be shifted like 20 days in 2,000 years.
Yeah,
the megalithic sites just wouldn't stay matching. If you change the
if you do, 45 BC to 2025 AD, that's 2,069 years. 2,069 divided by 71.6, that's 28.896 degrees. Days, and then times 365.2422 divided by 360. Yeah, there should have been a 29 days or 28.9 degrees. I'm just gonna say 29 degrees. I'm just gonna say 29 degrees of shift, because that's the other thing. Thank you for reminding me of that. That's the other thing, is when they corrected the calendar, they made, because it had been 1600 something years since the Julian calendar was put into place, and we know that even in 325 AD, the Council of Nicaea said March 21st is the equinox, right? So even if you measure from there, we'll just measure from there, March 325 to 1582, that's 1,257 years. So 1,257 years from the Council of Nicaea, March 21st, to the Gregorian calendar shift, March 21st. They only made a 10-day correction, and that 10-day correction was due to the calendar imprecision. They did not make a separate correction for equinoxial precession. They only made one correction. There should have been an equinoxial precession correction too if they were trying to fix it. But they didn't make one. There's never been an equinoxial precession correction made to a calendar. It's only been a calendar imprecision correction.
Nope.
I posted some of these examples in the chat.
Been the same since the beginning of time, brother. Nothing.
I posted some examples that have you see the portholes? I don't know what else to call them, dude.
Yeah, in the Stonehenge stuff or in the temples and stuff.
So these ancient temples, even in the ancient churches, somewhat ancient, they have these holes in them. And there's one in an Egyptian temple, and I'll post this one. This is from an astroastronomer from India. I don't know how to pronounce her name, but I posted it in the chat. She talks about this. I don't know if you heard about her. That's where I found this out from. Astronomical alignment of ancient monuments not changed. Ramses II between 1279 and 1213 BC, bro. It just happens to shine on his face consistently, dude, from year to year, according to the ancient records.
Yeah. I mean, it's just not happening. Like I said, all the corrections that they made, they were corrections made because of the imprecision of the calendar. They were not corrections made for any axial precession, any equinoxial precession. That did not happen. There's never been any of those corrections made. And even our current calendar, which has not changed since 1582, so we have 443 running years on this calendar, all staying the same, right? This 443 years, we have never made any axial precession corrections of any kind. We do not have a six calendar day shift in the equinoxes at all. the equinox is not on March 15th or March 27th. It's on March 21st every year, all the time. Or it's the 20th / the 21st, because depending on where you are, what hour of the day it falls on or whatever for you, it can be in between. But it's easy to say March 21st. It's March 21st every year.
I mean, of 27,000 years, or I forget the exact number. What's the years?
Like 26,000 something.
Yeah, it's 400 years out of 26,000. No, that's not a lot. You're probably looking at a fractions of an arc second or something. No, I don't know.
It's like 71.6 times 360. It's 25,776 years, I think, roughly.
It's significant, Jeremy. The solstices would shift considerably, bro. The Tropic of Capricorn and the Tropic of Cancer would shift from 23.4 degrees to like it's like 20 days, bro, in 2,000 years.
Yeah.
And yeah, they would move. The solstice would move. The equinox would move it. Yeah, the whole thing would shift. And
Well, I
it's
mean, I think
because
the
of
main
because.
point is you're focused. Go ahead.
Go ahead. No, you good. Go ahead.
Well, you guys are focusing on the calendar. I'd be more focused on the megalithic side of it, because those are the ones that's like set in stone. You know what I'm saying? Those haven't moved. Nothing's changed.
Well, the reason the calendar is important is if you don't reference the calendar, they can just say, oh, well, the position in Earth's orbit where it was the equinox back then is at a different position in the orbit than it is now. Because technically, you'll still get an equinox on there somewhere. It'll just be in a different position in the orbit, and so you'd have to reference it to all the other stars, and we don't have references like that.
Yeah,
so
but they'd have to say that, oh, they built these things as equinoctial markers before the equinox was even there, though.
Well,
You know
no,
what I'm
that's
saying?
what they say.
We just happen to live in the time where they all landed on the equinox now, and when they built them.
That's what they say, actually. So NASA has addressed this apparently, because this was brought up, and NASA said that certain architecture in South America that they use as an example to show that why are these megalithic sites still lining up when they were built 1,000 years ago? And NASA's excuse was, well, because those cultures built the monuments with a future generation in mind.
I've never heard them actually admit that, because that would be the only. Jeremy, what you're saying is correct if you have an objective calendar basis to go off of. And so the reason I use the post-Gregorian reset is because now that we have the Gregorian calendar, everybody has to openly acknowledge that we have a year marked down precisely. And so none of the effects can be offset by any imprecision in measuring the 1 year equals 1 year equals one full revolution. So now that we have that as like an objective basis, then we can eliminate all other sources of deviation and error and focus exclusively on axial precession. So with this 443-year window, right, we don't have to worry about anything else other than axial precession. And so that's why I try to focus on that. But you're not wrong. It's just that but I feel like if you tried to just only focus on the alignments with the equinoxes, right, what they would say is, well, the thing is on the day of the equinox, whenever that equinox is, when the equinox itself does occur, right, when it does occur, that's always going to be relative to the Earth being pointed like this certain way at this certain time. And they could just say that when it occurred back then, they built it for the equinox, and the equinox back then was just on a different day on the calendar. So it was in a different day in our civil year, in our calendar year, but it was still the equinox. By having a calendar, now we can force them to be like, oh, it was at the same day of the year. It was at the same point in the orbit. Now you have nowhere to go. You can't try to move the Earth around in the solar system frame, in the sun-centered inertial frame.
Yeah, the calendar has to be in sync with the luminary. If not, then yeah, you could have spring be arbitrary, depending on the calendar. It'd just be arbitrary. Spring would just be 20 days earlier, and you couldn't prove it.
Right.
You get what I'm saying? But like the important thing is, bro, is that the sun and the moon have been faithful in their orbits. They have not deviated from their orbits, and that the stars have their own gear that precess independent of the sun and the moon's position. Right. So the sun and the moon are returning to the same position. The ground position, the subsolar point of the sun is consistent. And the timing is consistent with the calendar, yet the stars are precessing independently, showing that the Earth is stationary.
Right.
And that the sun and the moon are fixed in a specific circuit around the Earth. That's the significance of all of it.
Right. You cannot claim that Earth motion is causing the stars to precess while the sun and moon positions and paths relative to the Earth don't change. Everything would have to change simultaneously, and it doesn't. It's only the stars that we see changing. So it can't be caused by Earth motion. That's the point. It proves that heliocentrism is false. Which is likely why this is not a well-learned or largely discussed part of astronomy.
I think they did it specifically with the time equation with the backdrop of the stars instead of a sundial on the Earth, so you wouldn't notice it.
Yeah, that's
Well,
another good point. Is that they use the backdrop of the stars as their main reference point to anchor the years, right? So they use the sun, but they reference the backdrop of the stars instead of using the Earth for the
right,
sidereal year.
right. They anchored the sun to the stars instead of the sun to the Earth. And then when they
Yes.
measure the Earth against the stars, like there's no answer as to which one it is that's turning.
Exactly. Yeah.
Exactly. Yeah, I've been studying this for a while because me and Tora and others, we're in the Zadok community, so we study the Zadok calendar. But like, people that bring up the 4-quarter Earth theory? You come across that yet?
What that there's like outside of the ice circle, like it tapers off into a square far out there.
Like, there's a greater circle, right? There's the known world, and then beyond the ice, there's the unknown world, the undiscovered world, and that there's this procession that occurs around a greater circle of thawing and defrosting. Right? So like right now, like
Oh.
it just happens that our known world is so in the 26,000 year cycle, there's this circle that rotates around a greater circle, and we just happen to be living in a time where our geographical location has defrosted. 12,000 years ago.
As if there's like a glass dome over top of a giant circle map, and then like the circle covered by that glass dome is the thawed out part of the world that we have access to. But then like over 26,000 years, that glass dome gets slid across that circular table, and the part under the glass dome is now a different part.
Right. So we should be seeing not only defrosting on the east side of this greater circle, we should see on the west side like it freezing up, and then the sun and the moon should be slightly shifting, clockwise or counterclockwise. I can't remember, but it should be slightly shifting a little bit every year, and it's not. And this is the biggest evidence against the 4-quarter Earth theory, because I was entertaining that theory until I came across archaeoastronomy debunking that theory thoroughly. There's no 4-quarter Earth theory here.
Right. I mean, we just live on an Earth, and it is what it is, and it hasn't moved.
Yeah.
Yeah, I agree, man.
And it doesn't have to be icy. I don't know. I think it might be renewed to the land not being icy anymore, more habitable, tropical.
Mm-hmm. I mean, I think that this is not substantiable by anything I can say. But like, if you look at like how the climate of Earth is thought to have shifted over the past 6,000 years or whatever, 4,000 years, whatever, post flood time, however you want to look at it, I think that the weather patterns are influenced by Earth's geomagnetic field, and the geomagnetic field alignment is affected by the sum of the celestial bodies' alignment and orientation. So like over time, when the celestial sphere precesses, it causes deviations in those alignments, which cause changes in Earth's geomagnetic field, which causes weather pattern shifts. So they can explain like why, like back in certain eras, like different parts of the Earth were colder or warmer than they are now, because they feel like they know pretty well that parts of Antarctica used to not be frozen. But that the sun hasn't changed its course, so the amount of sunlight in those areas wouldn't have changed. Like you still get full sunlight in Antarctica in the southern hemispheric summer, and yet it's still super super cold there. And so it makes you wonder, like, okay, well, what if like the geomagnetics change enough to get the wind currents to change enough to move it up from 25 to 35 degrees? Because I think when Whitsitt and them were on their trip there, it was like the height of summer right down there, and they were in like the 20s during the day. So if you move from the 20s into the 30s, now it's not frozen anymore, or the 40s or whatever. Like you don't have to gain that much of a temperature, so it could explain some things like that. But that's neither here nor there.
There's solid evidence that Antarctica used to be temperate, dude. Like just petrified, deciduous material, and there's even maps showing Antarctica fairly recently. Now I don't know what to believe about these maps, but like even the Monte map shows Antarctica to be like a desert climate in certain areas, bro, and a temperate region in others. I don't know what to believe, dude. But just 500 years ago, dude, I don't know. What do you think?
500 years? I don't know over what time periods the climate shifts. I mean, definitely over many centuries, but I don't know how many centuries that is. Millennia for sure. I don't know, like century to century, how much it does. Because the thing is, like, we don't have weather, so we don't have like substantial weather records beyond like a few hundred years ago. I know that there's like a mini ice age in like the early 1800s, like the 18 teens or something, maybe.
The other funny thing about what you're saying, it's weird that you're bringing it up, because last night I was showing my wife the calendar. Even on your iPhone, if you go back, what did you say? It was 1582, and you go to October 4th, and you see there's 10 days missing.
Right. Yeah, and this is actually relevant when you start looking at the prophecies in the book of Daniel to calculate like all the years. That like the 483 years from the order to like restore and rebuild Jerusalem until Messiah the Prince. And you can do that. You can calculate when it happened, but then people say, "Oh, well, this doesn't fit in with like our current calendar." When we look at the Hebrew, like it's off by like a year or two. It needs to be this year, not that year. But then when you go and you realize that the Hebrew calendar didn't shift 10 days, it's just our civil calendar did, and you do a 10-day shift to align it with it. Now all that stuff falls on a different day of the week, and it lines up with the proper year. So like it's also relevant and stuff like that.
Yeah, I mean, the modern Jewish calendar, the reason that the Nicene Council changed, they were dependent on the Jewish reckoning of time, but the Jewish reckoning of time was a hot mess, dude. And even Hillel II had to fix the calendar to the monotonic cycle of the moon. You would think that if these were truly God's chosen people, that they would have been preserving the calendar that was, bequeathed from antiquity, from basically Solomon up to the rebellion that occurred in the Maccabean revolt with King Antiochus Epiphanes, bro. But they weren't. They were on a completely different calendar that was manufactured by the Hasmonean dynasty. It was not the ancient calendar that Solomon was on, or King David, or Moses, or any of them for that matter. It was because if you look at like Enochian literature, the Zadok or the Dead Sea Scrolls, Jubilees, they were on a completely different calendar than what the modern Jews are on today. And because of that, so early on, first, second, third century, they were on a calendar that was processing backwards, and the springtime or the beginning of the Jewish calendar or Passover was being kept a month before the spring equinox, dude. A month before the spring equinox, the Christians were like, "Yeah, we got to do something about this. Can't keep following."
It still happens today. It still happens today. Sometimes, like some years, the Easter will be a month, like on a different month than Passover.
So yeah, the Christians came up with their own calendar based off of the moon and the first crescent after the equinox, and they fixed Easter since then on, because Easter before was drifting through the year, which was a big problem.
It's still not synced up with Passover. Some years it falls really close, and some years it's a month off. It just depends on the year.
And then they started like figuring out, the every 3 years the Jews add a month, known as Resh. I forget what they call it, Sheena, something. They had 30 days.
See, do we have enough data, like enough specifics, to accurately and fully recreate the ancient calendar system of like those days back, like Solomon era and pre?
Yes, sir. Yes, sir. We're basically 95% of it has been figured out. There's some debate in the community between when to intercalate a week.
Piezo's coming to Jerusalem with us in 2028.
Yeah, I'm trying to make a trip to Jerusalem in 2028 when it's reckoned that that's the next intercalation that should occur.
What's supposed to happen?
There's something incredible going on with the sun's position, dude. So if you measure the sun's position on the equinox, where it actually is in the sky geometric position, it actually oscillates ever so slightly from year to year. So if you were to track its ground position on the ground, it shifts about 20 miles, 14 or 20 miles from year to year. And it oscillates. It goes, once it completes, like it will go south up to 70, I want to say 70 miles, around 70 miles. And then all of a sudden, like the following year, dude, you'll see it move up north of the equator. So it goes, it's still 0 degrees. You got to understand, 0 degrees latitude is how many miles from north to south?
It's supposed to be 69 miles per degree.
Right, it's around 70 miles. Right, 0 degrees latitude, around 70 miles. The sun shifts between 0 degrees latitude ever so slightly. So it's still 0 degrees latitude. It's still over the equinox to equinox, but it's actually shifting ever so slightly its geometric position. Fractions of a degree latitude.
Let me ask you this. Are you saying it's a continuous oscillation, like it draws a continuous line year after year? Or are you saying that like at some point it just teleports 1 year from south to north instead of tracing its full path back?
No, so it will oscillate ever so slightly, but it will incrementally shift from year to year its ground position about 20 miles until it reaches its maximum line of demarcation, right? Offset. Then it will just completely move upwards, like almost, I want to say, almost like 60 miles or something like that.
Well, that's what I'm asking. So like, let's say that we're drawing a sine wave where the maximum top amplitude is like half a degree latitude, and the maximum bottom half amplitude is negative, half a degree latitude, and we're drawing a sine wave between that. So let's say that we start at the equator, and this, right now the sun's moving up over the years, and then it hits its maximum and it starts moving down. Are you saying it continues to follow that sine wave in small increments, or are you saying it, like once it reaches the top of the sine wave, it teleports to the bottom?
Yes, it does, like what a typewriter does when you reach the end of the heading.
Oh, so it'll go from like top to midpoint to bottom, and then when it reaches bottom, it teleports back to the top again.
Yeah, yes.
Is that the every 4th year thing?
So yeah, and that's around every 4 years. It's very precise. The Hebrews understood this, and it was a time marker that allowed them to know when to intercalate, dude. It's pretty. I mean, it's pretty fascinating stuff, dude.
Yeah.
But
So
the
why
modern-
would it should modern would say that it should follow the continuous sine wave. It shouldn't be like an instant reset. It should just be continuous up and down and back up again, right?
Yeah, it destroys the heliocentric
Well, yeah, but
model.
they they added wobbles, and obliquity, and eccentricity to make up for all that stuff. So they always have their ways of making it work.
Because those things are
The up
true.
and down, the not up and down Antarctic sun. Is that what you guys are talking about?
Yeah, because it's observed, it's measured.
Oh, this Kepler guy's back. Man, you dipped out and you missed the entire lesson, bro. That destroyed your model. It's too bad you weren't here for it.
It's impossible. You can't destroy the model. You can't.
Oh,
It's
you're saying you have an unfalsifiable model?
unfalsifiable.
That makes it non-scientific by definition, GG.
Yeah, everyone, if he wasn't here, you didn't debunk it. No, hang on, Robert. Hang on, Robert. If you weren't here, then it wasn't debunked, right?
It cannot be debunked.
Yeah, you can't debunk an axiom.
Yeah, because you weren't here.
The Earth is a
So
globe.
then it's a miracle, right, Robert?
The
It's a
Earth is-
miracle. It's not
The
science.
Earth is a globe because it's an empirical observation.
There's
well,
no
then it could
such
be-
thing.
Then it could be
Like a
empirically.
It's not a-
It could be.
it is
Hey,
not
if
a-
it.
Say it with your
Whoa.
chest.
The globe is
Say it.
not a scientific model
Say
anymore.
it with your chest.
It's an empirical observation now. It's like
Say it
it's
with
There's
like a
no
rock.
such thing, Robert, as an empirical observation.
Empirically
That's
observed.
stupid.
It's a double positive.
Empirical has to do with measurement, doesn't it?
observation. It's like me drinking water. If I drink a glass of water, I have drank a glass of water. You can't tell me that I've not drank a glass of water. It is an empirical experience.
No, dude, we get you. It's an axiomatic, circular, self-attesting truth that is
No,
a priori
self-
known upon birth. We get it. It's a globe.
empirical locked-in observation by almost 1,000 individuals have seen.
No
It's
thanks.
over.
That was hilarious.
Yeah, no thanks. That's
Yo,
good.
yo,
We did
Kepler, I
double
have a
entendre.
question for you. Let me see if you have the answer. Let me see if you have the answer. Okay. So,
Right, bro.
as you probably know, in 1582, we made the.
1582. Oh Lord, we're going way back again.
In 1582, we switched to the Gregorian calendar because we needed to make sure that our definition of a year was accurate. Correct?
Right. Okay.
Okay. So now that we have made an accurate definition of a year and we're on the accepted Gregorian calendar so that we know every year, 1 year equals one complete and precise orbit around the sun. So 1 year means one reset back to the starting point. Okay. Now that we know that, then the only thing left in terms of calendar shift would be due to the precession of the equinoxes. So every 71.6 years, Earth's
That's right.
axis is supposed to precess 1 degree. Okay,
Yes, sir.
so there have been 443 years that have passed since that calendar was instituted, which equates to just a little over 6 degrees, which means that the date of the equinox should have shifted by 6 days since 1582. The date of the equinox in 1582 was March 21st. Do you know what day it was this year?
Have you ever heard
It was
of
March
leap year?
20. It was March 21st. Yeah, that's
Have you
included.
ever-
That's included, and the full leap year cycle. The
Leap
full
year.
leap year cycle to return to perfect symmetry is 400 years, which we are
It would
past
take
that point now.
26,000. It would take 26,000 years.
No,
But
that's
I
to
want
do
to
a full
complete-
300. That's for a full 360-degree precession, my
Exactly.
bro. The leap year.
26,000 years.
Okay,
to make
you're
that full
missing.
cycle.
You're missing the point. That's not
The
what's
6
in
degrees is
question here.
nothing. The 6 degrees is nothing.
6 degrees is 6 days on the calendar, though. And since you just
No.
agreed that since you
Absolutely
just
not.
hold on, since
Stop
you just
flipping.
agreed that the calendar is accurate and precise, which is the reason that we changed it.
I never agreed to that. Did I agree to that?
Stop
No.
flipping, bro.
Since the calendar is accepted to be precise, 1 year is 1 full orbit reset back to the starting point, and we know that, then that means over 443 years, you have to have 6 degrees of precession so that on the same calendar date, we're at the same point in the orbit. So at that same point in the orbit on that same calendar date, compared to 443 years ago, Earth's axis is pointing 6 degrees in a different direction, which means the equinox should not occur at that point in the orbit. It should occur 6 days before in the orbit, and it's not doing that. It's still on March 21st. Your model is broken.
No, your March 21st. March 21st, brother, is man-made number. Man-made number. And the reason why it's March 21st
Sure.
is because of the leap year. It's because of the leap year and February 29th. And February 29th. You forgot that.
So you're just ignoring everything I just said.
Yeah, brother, you didn't. You're deliberately excluding leap year The
I'm
February
not excluding
29th
it.
date.
It's implicitly included in the
366
Gregorian calendar. It's part of it, bro. You can't exclude it or include it.
Here's
It's just
another
part
thing
of
you
it.
don't know. Here's another thing you don't know, brother. When the axis is completing a loop, so what happens when it gets back to that? When it completes the loop, what's going to happen? It's going to get back to the same calendar, right? 6 days off. It's going to get back. It's going to reset back to the same calendar. So
Well, it's only
the
6
clock-
days off in 6 degrees. Like it would change incrementally up to a maximum of 90 degrees, and then back down to 180 degrees. It would become the same again.
So now we're back on track, correct? It would take, and this
We're
takes,
not on track. It's only been 443 years, bro. It should be off by 6 days, and it's not.
no, this is the leap year.
Okay, Kepler, listen, buddy. A leap year adds 1 day or takes away 1 day. Okay, and every 400 years you skip doing a leap year. So the leap year cycle is 400 years long, and it's only going to affect you plus or minus 1 day at a maximum. Okay, we're off by more than 1 day. We're off by 6 days. Where are those other 5 days? Even if I grant you the leap day.
We had this discussion.
No, brother. Again, you cannot exclude the leap year. The leap year is what adds. The leap year is what adds back on your days.
Yeah, the leap year is what ensures that the definition of a year is getting us to where the Earth is back to the same exact point in its orbit year after year.
Right.
It's like he's not even listening to you. He's just waiting for his chance to disrupt the conversation.
No, he's
hilarious. Robert, you need to be.
He's circling you. None of you understand what he's saying. Let me first of all say that. None of you.
No, you don't understand what he's saying. I fully understood what he was saying, Robert.
On this stage, I will put money on it. I am the only one on this stage that knows what he's talking about.
Oh my
None
God!
of you
You put money on it?
He's the
I bet
only
you
one.
never pay. I bet you never pay.
Yeah,
Just like Jesse.
I would
You're
pay.
a liar.
I would pay
Get
money.
out of here,
I'll
bro.
pay money.
Jesse never sent you that tool?
I'll pay money. I'll pay money. So guess what? He knows what he's saying. He did the research. He deliberately is excluding the leap year.
No, he's not.
He knows the leap year.
Explicitly explained the leap year cycle to you.
No, brother. You know the leap year would do the reset. So and you were mad. You got angry. You got angry, and you know what you did? You circle jerk your audience to exclude the leap year. But here I come.
Oh wow.
That is false.
Here comes the boss.
Here comes the boss. Oh my God.
Where is the leap year? And then you know what you said? You didn't even mention the leap year
I don't mean to
earlier.
laugh over. I'm sorry.
Hold on.
You
Say it with your chest. Hey,
in your
you
first
didn't say that.
diatribe, in your first diatribe, you didn't include the leap year. You only mentioned the leap year when I said it.
I didn't need to mention it because it's part of the calendar. How could I exclude it? The calendar accounts for it. It's built in. That doesn't make sense.
I'm done. Oh, really? Is it built in?
Is February 29th on the calendar? Yeah.
You got hit, brother.
It's called an intercalary day. So these days are called specific.
You got hit, brother. I brought the leap year up.
He's literally being ignorant of the fact that you've already pointed out what the leap year does. And
No.
What it does is it keeps.
He deliberately left out the leap year.
It keeps the orientation.
He should have mentioned the leap year from the beginning.
He did multiple times. You're an idiot.
He didn't mention the leap year.
Stop flipping, Robert.
I thought he was. I thought you were like fairness.
Boss.
Oh my God, fairness. He was all about fairness. Stop clipping. And his boss routine is literally to be like Q-Up or Nathan Oakley or any number of people who just shout over you.
Here comes the boss.
You're so small.
The boss came in and
is Danny like, I would love to continue my conversation with Danny from a week or two ago.
No, you didn't mention no leap year.
Okay. All right.
Yeah, Danny just popped in. Danny, you around?
Yes. The leap year has nothing to do with what you're talking about.
Thanks.
Robert.
Come on, guys. I am the baddest. I cook flat earthers for lunch.
Yeah, so Danny, I appreciate your method of discussion. We had a good discussion a couple weeks ago, and what I did is I made sure to go and study more.
He's going to go back and do the research on the leap year now. You're watching.
Robert, take a back seat, bro. Take a back seat. Robert, chill out. Take a back seat, bro.
He just told you were wrong, bro. Like, relax. Anyways, I went back and was doing research on the calendars and all that stuff, right, in order to be able to facilitate a further discussion and be more well informed on the topic. So basically, what I found, Danny, and you probably know most of this, but we were talking before you came in, is in 45 BC they instituted the Julian calendar, and they knew that the orbit of Earth around the sun in a heliocentric model did not account for a year in whole number segments of days. It was not exactly 365 days. So what they made it 365.25. But the problem with that was. Yeah, the problem with that was it's not exactly 365.25. It was 365.2422 or whatever it is. Insert X many decimal points. And so they were gaining, since it was a little bit too long, they were gaining about 11 minutes and 12 to 11 minutes and 15 seconds a year, depending on which reference you use. And so over time, it was building up a drift forwards on the calendar. So by the time you get to 1582, 1600 and 40 something years had passed, or 1620 something years had passed, 1626, I think. So they had gained roughly 10 days on the calendar due to the calendar imprecision. So in 1582, Pope Gregory ordered them to institute a 10-day calendar skip and institute a more precise a year marker, so that they instituted the leap year cycle that we now use, which is like every 4 years, but then there's like a century leap year, and then over the like every 100 years there's a century leap year, and then every 4 century leap years you skip a leap year, and that put it back on track in order for us to have a precise year, so that now we accurately reset back to the same point in Earth's orbit. And so now that we have eliminated calendar drift, because that's simply just calendar drift, that's not a physical